Hello, this Show Me video will be focusing on the trapezoid rule. The trapezoid rule will allow you to find the area under a curve using trapezoids. As the number of trapezoids increases, you will get an answer that is closer and closer to the true value of the area under that curve. This is the equation that you will use to find the area under the curve. Area equals the last x value in the integral, or b in this equation, minus the first x value in the integral, a in this equation. You will then divide that by 2n. N in this equation is the number of trapezoids that you will be using to get the area under the curve. For example, in the diagram below, the n value would be 4. You will then multiply this by the y value of the first value, a, plus 2 times every y value at every increment after that, until you reach the final y value at b, which you again will only add once to the equation. The reason that you are only adding these once into the equation is because these are the values that are represented on the far left and right sides, as shown in the diagram below. They are only one side of a trapezoid and therefore only needed to be added once. All the trapezoids need to be equal in width, so to determine their width you will need to take the distance between point A and B and divide that by n. Okay, now let's try this out. In the first example we are given the prompt that n equals 8 and that we must find the area. So, what we need to do first is make sure that the table we have been provided with has an n value of 8. To do this, we find n by subtracting a from b. So, b equals 9, and then we subtract 1 from it, then we do actually see that n is indeed equal to 8. Now that we know this, we can move on to plugging everything into the area formula, as shown. With this formula, we will then be able to find the area under this curve. So, what we do first is we plug in b minus a, 9 minus 1, as we did earlier. That gives us 8. Next, we divide that by 2 times n. 2 times n is 16, so we see that the first part is 0.5. So now that we know this part right here is equal to 0.5. With that information, we can then move on to the next part with finding out the value of the larger sum. So we need to add once the first value of x plus 2 times every value preceding until we get to value 9. So 2 times 50 is 100 plus 2 times 54, which is 108, plus 164 plus 164 plus 146 plus 150 plus 160 plus 10. Whoopsies. Plus 10. That shows us that the larger sum of this is 1012. So now that we know that, we can then multiply these two parts together to get the area. So the first part, as you remember, is 0.5 for this. So we multiply 0.5 by 1012, and we know that the area is equal to 506. So then the next example, we'll be using a curve that doesn't perfectly fit the table, and we'll have to be getting an estimation for it. Okay, now in example 2, we will be using the trapezoid rule to find the area under the sin x curve from 0 to pi when n is equal to 4. So, the first thing that we need to do is find 5 equally distant points from each other between 0 and pi that are under this curve. So here these 5 points are. Now each of these points are equally distant from each other and divide into 4 different trapezoids under this curve. And then what we do is we take these values that we've got and plug them into the trapezoid area rule so that we can find the area under this curve. So we take b minus a, b being the highest value, which is pi, and then we subtract the lowest value, which is a, or 0 in this case, and we get pi. Still the same thing. And then we divide that by 2 times n. Now we know in this case n is 4, and we just multiply 4 by 2, which gives us 8, and we've got this super long fraction. So if you're working this out on a calculator, you would store this value, or in the case of me, I'm on a computer, so I'll just copy it. Now that I've got that for later. So let's clear the calculator, and let's move on to the next part. Now we need to add the first value, which is 0, plus 2 times the second value. So with the second value being root 2 over 2, I can just multiply that by 2, and I will just cross out the divide 2 part. So all I have to do is then add 2 root 2. There we go. And then we go plus 2 times 1, so that's 2. And then we just have 2 root 2 again, because it's the same thing, so we're just multiplying that by 2, and that's staying as root 2. So there we go. And then we have plus the last value, which in this case is 0. So I guess we'll just add that in for the laugh. And then we hit enter, and that gives us a number which we have for the larger part of this. So now we take this part of the equation and we multiply it by the first half of the equation, which we have stored in our calculator. So we'll multiply that by the old number, which, as you see, is the same number we got at the first part, and we have 1.89612 roughly. Now, the true value for the area under this curve is exactly 2, and if you use an integral from 0 to pi and plug in the equation for this line, then you'll see that the value is 2, but the trapezoid rule is just used to estimate the area under a curve. So this is underestimating it by roughly, let's see, we'll grab the calculator back, and we'll keep this number. 2 minus that gives us 0.1. So it's roughly 5% off, but if you weren't able to simply plug this into a calculator and you were trying to do this all by hand, then that would be pretty good considering you're just using basic addition and multiplication to come to a value. So that is all, and I hope you enjoyed this lesson.